Okay, we are in the last section of chapter 14. We are going to talk about the determinant of a square matrix. Okay, so first of all, what is the determinant? Here we have the definition of the determinant. It's sort of not a formal definition, but it is a number associated with a matrix. And this number is important because the number helps you determine um, the types of solutions that a system of equations with that leading coefficient matrix would have, whether or not that solution is unique, and whether or not the square matrix will have a determinant. And right here we have the theorem that states that. If your determinant is 0, then there's no inverse for that square matrix. Okay, so we want a non-zero determinant. Okay, so we start off, and so we're just finding the determinant, and the determinant is just a number. It's associated with the matrix, but it's just a number associated with the matrix. This whole lesson is on finding determinants. We start with the determinant of 2 by 2 matrices, okay? So this is important because everything boils down to a 2 by 2 matrix. So what is the determinant of a 2 by 2 matrix? So here I have a matrix A, and I think I need to name the elements A, B, C, D. So they're A, B, C, D. Then the determinant of A, okay, this is one way you can write determinant of A. You can write determinant parentheses A, so that reads determinant of A. Also, we use absolute value bars, okay? Absolute value bars, and that's what you'll see most often because that's the notation I like to use. It's less writing. So the determinant of A, or the determinant of this A, B, C, D matrix, and now notice that I have just the absolute value bars and not the actual matrix square brackets. The way this works is you do A times D minus B times C. And you have seen this number before. It should be familiar. In the determinant of a 2 by 2 matrix, or sorry, in the inverse of a 2 by 2 matrix, we divided by that. 1 over AD minus BC, and you multiplied that where you switched the D and the A and you negated the B and the C. This is the inverse of the 2 by 2 matrix. And so you can see why we need this to not be 0, right? Because if the determinant were 0, then we would be dividing by 0. That's not allowed. And so that's when you do not have an inverse. So the determinant of a 2 by 2 matrix is simply AD minus BC. I have two examples here for us to work out. So number one, the 2 by 2 matrix, 2, 3, negative 1, 5. And so what's the determinant of this matrix? That would be 2 times 5 minus 3 times negative 1. So that's 10 plus 3, 13. All right, it's as simple as that. Now here's number 2. So the determinant of this matrix is going to be, if I do the determinant of it, negative 2 minus negative 1 times negative 2. So that's negative 2 minus negative 2. No, negative 2 plus 2. 0. No, hold on. 3 negatives, that's still negative. Negative 2 minus positive 2. So negative 4. Sometimes you get 3 negatives, and that's still negative. All right, so this determinant is negative 4. So 2 by 2 matrices are very simple to find the determinant of. It's just the formula AD minus BC. All right, so we're going to talk about something called minors and cofactors. And the reason why we have to do this is because when you have a matrix that's larger than a 2 by 2, the way we find the determinant of larger matrices is we reduce it to a sum of determinants of 2 by 2 matrices. Okay, so larger order than 2 by 2s, we have to reduce it down to 2 by 2s. And this is the method of using minors and cofactors. Okay, so, and these are just fancy words. As long as you know how to do it, you'll be fine. So the way that we do the minor of an element, okay, so minors and cofactors, these are per entry, per matrix entry. So each matrix entry has an associated minor and cofactor. Okay, so the minor is the determinant of the matrix you would get if you knocked out the row and the column of that minor, or of that entry. And then the cofactor is plus or minus the minor, depending upon where the entry was. Okay, so it's either multiplied by 1 or -1 on the checkerboard of plus and minus signs. And all checkerboards alternate, and you start at the top left with a plus. So here's a checkerboard of plus and minus signs. And you just keep going. It just alternates pluses and minuses everywhere. That's why it's a checkerboard pattern. Okay, so we're going to start with this 3 by 3 matrix here. And the way we're going to do this is I just want you to find the minors and the cofactors of this matrix. So let's call this matrix A. And so this entry right here, A11, is -2. The entry is in the first element. This is in the row 1, column 1 spot. And so I'm going to find minor 1, 1. And to do that, notice this -2, I'm going to cancel the column it's in, and I'm going to cancel the row it's in. And when I do that, I'm left with a 2 by 2 matrix. And so the minor associated with the 1, 1 position is the determinant of this matrix that's left. Okay, so I just took this matrix that's left, and I'm going to take the determinant of it. And this is what we just did. So that's -4 minus 0, -4. So minor 1, 1 is -4. Okay, now there are 9 entries in this 3 by 3 matrix. There are 9 numbers in there. And every single one of them has a minor. And we're going to work on finding all of them. Okay, so now let's work on the next one. I'm going to erase all this. Let's go to this entry right here. Okay, that would be row 1, column 2. So I'm going to find the minor in row 1, column 2. So to find that, I cancel the column it's in, and I cancel the row it's in, and I have a 2 by 2 matrix left. It's kind of hard to see because there's a deleted through the middle of it. But that would be the determinant of what's left, which is a 1 and a 0 from here and here, and a 0, 4 from the bottom two. And so the minor in the 1, 2 of the 1, 2 entry is the determinant of this matrix, which is 4 minus 0, or 4. So minor 1, 2, minor of row 1, column 2 is 4. All right, I'm going to go back, erase this work. Let's find the minor in the 1, 3 entry. So minor 1, 3. Okay, so I now delete the row and the column that is in, and I'm left with the 2 by 2 matrix 1, -1, 0, 1. And now I find the determinant of it. So 1 times 1 minus 1 times 0 is 1. Right? Multiply here, multiply there, subtract. Okay, so minor 1, 3 is 1. And we've done the entire first row's minors now. Okay, let's continue on and do the other 6. All right, let me kind of copy this down here. Now we're going to work on second row. So let's do minor row 2, column 1. All right, so I cancel the column in the row that element is in. Do you see the numbers left? 2, 3, 1, 4. So I do the determinant of that matrix, which is going to be 8 minus 3. So that's 5. All right, now let's move on. I want to do minor row 2, column 2. So that's the determinant of -2, 3, 0, 4. And that's going to be -8 minus 0, or -8. Last one. Oh, well. Okay, so now what's the minor of the row 2, column 3 entry? That's going to be -2, 2, 0, 1, the determinant of that. And so this is -2. Okay, now I want you to pause the video at this point, and I want you to find the final 3 minors. Okay, we're not done with this example because we have to find the cofactors still. But I want you to pause the video and find the minors of the last row. So you're going to find minor 3, 1, minor 3, 2, and minor 3, 3. Okay. Okay, so you should have paused, taken some time, and written out the final 3 minors. Now we're going to go back to our minors, and we're going to talk about the cofactors. This is a simple step, okay, not much more. So each minor has an associated cofactor too, and it's the same as the minor, except the sign might be opposite. And that all depends on the checkerboard pattern. So this is, in this 3 by 3 matrix, we have plus, minus, plus, minus, plus, minus, plus, minus, plus. And so what you do for minor 1, 1, that's this one in the positive entry. So you're going to multiply this answer by positive 1. Well, that's not going to change it any. So cofactor 1, 1 is the same as minor 1, 1, and that's always true. But now let's go to our minor 1, 2. What's cofactor 1, 2? That's not going to be 4. That's going to be negative 4 because minor 1, 2 lands on the negative spot of the checkerboard. So cofactor 1, 2 is negative 4. And cofactor 1, 3 is going to stay the same because that's in the positive spot. And now in the second row, minor 2, 1, that's on a negative. And so cofactor 2, 1 will be negative, the opposite of what I got. So you just negate whatever it is that you had, whether it was positive or negative, you change the sign. So cofactor 2, 2, that's a positive, so you keep the sign the same. You don't multiply by negative 1, you multiply by positive 1. And for cofactor 2, 3, I'm going to take negative 1 times negative 2, and that's 2, because minor 2, 3, row 2, column 3 lands on a negative spot in the checkerboard. Okay, so now your next task is for the minors that you calculated when you were paused. I want you to go back and tell me the cofactors. And they're going to be the same number, they just might be different signs, okay? So go ahead and pause and redo that, and then come back. Okay, so now we're on to our second example. And this is a 4 by 4 matrix. We're not going to do this whole example because it's going to take a long time. And that's because there are 16 entries. And so this is one example, not 16 examples. I'm going to, I don't know what example number this is, I think 4. So we're going to work on, I'm just going to show you the minors and the cofactors of row 1. Okay, so I'm just going to show you the minors and the cofactors of row 1. And that's only 4 of them. But it's a plenty of question, believe me. Okay, so this is a 4 by 4 matrix. Let's find minor 1, 1. So to find minor 1, 1, I'm going to go to my 1, 1 entry, and I'm going to cancel its row and column. And so I just need to take the determinant of the matrix that's left, which is a negative 1, 1, 0, 1, 2, 0, negative 1, 1, 1 matrix. Well, this is a 3 by 3 matrix, not a 2 by 2 matrix. And so I don't know how to find the determinant of that because I haven't showed you how to do that yet. And so let's come back to this question, and because it's gonna let me show you how to do the determinant of a 3 by 3 matrix, and then we'll come back and find these minors. Okay, so here's how you find the determinant of any square matrix. So you're going to choose any row or column that you want in the matrix. And you're going to find the minors, or you're going to find actually the cofactors of the entries in that row or column. Then you're going to multiply those to the entry and add them together. Okay, so let me show you how that works. The best thing to do are examples. And so here is a 3 by 3 matrix. And so we're going to find the determinant of this matrix. So you get to choose any row or any column. And the best thing to do is to choose a row or column with zeros in it. So I'm going to choose the third row because it has a 0 in it. And so I choose the third row. And the way we do this is in that row, I only need to find the cofactors of those elements. And so start with 0, okay? So I'm going to start with 0. And what you're going to do is you're going to take 0 times its cofactor. Okay, well, to find its cofactor, you would do the determinant of 2, 3, negative 1, 0. But it doesn't matter what that determinant is because I'm going to multiply that by 0. And so you get 0. By the way, the cofactor, this is in a positive spot, so I would multiply by the positive of that determinant. Now let's move on to the second entry in the third row because I'm using the third row. So I'm going to do 1. So I'm going to do plus 1 times the cofactor associated with 1. So I cancel the row and column that 1 is in, and I do the determinant of this matrix, negative 2, 3, 1, 0. Now, 1 is in a negative spot because we have plus, minus, plus, minus. It's on the negative part of the checkerboard pattern. So I'm actually going to minus that because when I do the cofactor, it would be negative. So I do this, so I have 0, and then this determinant is 0 minus 3, -3, so -1 times -3 is positive 3. And so this is my first entry of the row times its cofactor. Then the second entry of the row times its cofactor. I only have the last entry of this row to do, which is 4. So I cancel its row and column, and I do the determinant of the 2 by 2 matrix that's left, -2, 2, 1, -1. And notice that this is in the checkerboard. Oops, this is in the plus spot, so I will add it. I won't have to do a negative there. And so the determinant of this is 2 minus 2, oh, that's 0. So plus 4 times 0. And so the determinant of this matrix is 3. The determinant of this 3 by 3 matrix is 3. So you can see that to do the determinant of a 3 by 3 matrix, that involves doing 3 2 by 2 matrices. All right, so let's go back to this example here where I was working on finding the minor of an element that's in a 4 by 4 matrix. So to find the minor in this of the 1 1 entry, I canceled its row and column, but I got a 3 by 3 matrix. Well, now to do the determinant of this 3 by 3 matrix, I have to do minors and cofactors again. And so you want to choose the row or column. You only have to do it for one row or column. That's how a determinant works. And you want to choose the one with the most zeros. So I choose this column. It has the most zeros. And I do 0 times its cofactor, but that doesn't even matter because it's 0. And then plus minus, so that was in the plus, minus 0 times its cofactor, which would be -1 1, -1 1, but that doesn't even matter because it's a 0. And now finally I have this last one left, 1 times its cofactor, and that would be -1 1 1 2. Okay, and so that is going to be 0 minus 0 plus -2 minus 1 is -3. And so this has a determinant of -3. And so minor 1 1 is the determinant of this 3 by 3 matrix, and so it's -3. All of that to do the minor of one entry in a 4 by 4 matrix. And a 4 by 4 matrix has 16 entries. This is why we're not doing all 16. Let's work on minor 1 2. So minor 1 2, I'm in row 1, column 2. I'm going to cancel its row and column, and that's the determinant of this 3 by 3 matrix. 1 1 0, -1 2 0, 0 1 1. And so what is the determinant of this 3 by 3 matrix? Well, I pick any row or column. So let's pick column 3 again. It has the most zeros. So we're going to do 0 times the cofactor associated with that one, minus 0 times the cofactor associated with the second 0, plus 1 times the cofactor associated with this last one, which is 1 1 -2 -1 2. Ran out of space. 1 times 1 1 -1 2. There we go. And so this is 0 minus 0 plus 2 minus 1 is 1. 1 times 1. And so this minor 1 2 is 1. But notice minor 1 2, is the cofactor 1 2 is -1 because it's in the negative spot of the checkerboard pattern. Okay? And let's stop that. Let's stop with there. We found 2 minors, and cofactor 1 1 is also the same. Let's move on. The final example. Well, no, it's not the final example. We're going to find the determinant of a 4 by 4 matrix here. And this is extensive because it is, again, a 4 by 4. So to do this, I'm going to choose the row or column with the most zeros, just like we just did. And that's the fourth column. Again, it has the most zeros. So I'm going to do the cofactors of every element in that column. So I start with -1. I cancel its row and column, and I get the 3 by 3 matrix 1, -1 1, -1 1 2, 0 -1 1. Okay, now the next two I don't have to worry about because it's 0 times something and 0 times something. And now the last one. Okay, hold on. This was plus, minus, plus. This is in a minus spot. So I need to negate negative 1. Negative, negative 1. And so that's minus, plus, minus, plus. So the last one is a plus again. And let me clear that up. So for this one, I have in this final entry, it's in the plus spot. So this is positive 1 times the determinant, negative 1, 1, 0, 1, negative 1, 1, negative 1, 1, 2. All right. Now, we just have two 3 by 3s to figure out. Okay, so let's work on this 3 by 3. It'd be easiest to use this row or column. It has a 0 in it. So I'm going to do 1 times 1 to negative 1, 1, because I cancel the row and the column. Then this negative 1 is in the negative spot, so plus 1 times, and I cancel my row and column. I get negative 1, 1, negative 1, 1. And then finally, the last one is that 0, so it doesn't matter what I multiply by. Okay, and so this is 1 minus negative 2, so that's 1 plus 2, 3, plus negative 1 plus 1 is 0. So that's 3, and then I had negative negative 1, which is 1 times 3, so 3. So that's the first part. It's not the whole determinant. 3, I just did this part here. Now I have plus 0, and I have this last 3 by 3 determinant to figure out. Woohoo! So let's do row 1. Okay, so for row 1, I have 1 times negative 1, and I cancel its row and column, and I get negative 1, 1, 1, 2. I'm going to run out of room. And then the next one is in the negative spot, so negative 1 times 1, 1, negative 1, 2. And then the last one's a 0. So, all right, so here I have negative 2 minus 1, that's negative 3. Negative 3 times negative 1 is 3. Minus 1 times, this is 2 plus 1, 3 times negative 1, negative 3. And so this is a 0. Interesting. Okay, so my answer is 3 plus 0 plus 0 plus 0, which is 3. The determinant of that 4 by 4 matrix is 3. All right, so the last thing I have up here is another example, but I'm going to go ahead and stop here. I'm asking you to find the determinant of the 3 by 3A and the 3 by 3B, to find the product, and then find the determinant of that product. So I would like for you to stop this and go ahead and do this example question if you're feeling confident and you want to try it out, okay? I will tell you that I worked this out a little bit, and if I didn't make a mistake, the determinant of this one is going to be negative 23. The determinant of B I got to be 1, and then I got the determinant of AB to be 65, but I don't trust my arithmetic there. So go ahead and work it out and see what you get.